So to add these things together, we are going to get common denominators. Well, first you might want to factor this denominator. It really won't do anything for you because taking a 5 out of that is just going to give you, oh, no, it will do something. Definitely. So that's what that is, 5 times x minus 4. So what do I have to get? What's the least common denominator between this and this right here?
X minus.
It's 5 times x minus 4. So what do I have to multiply this by on the top and bottom? 5. So that's going to equal 2 plus 35 all over 5x minus 4, which is just 37 over 5 times x minus 4. All right, so let's do another problem. This one's a little bit trickier. I'm going to have to factor these things out right here first because they might have something in common, in which case I don't have to multiply them too much. I don't want to make it bigger than it has to be. So factoring this, remember, factoring this is the first. I know this -2 is probably -2 and +1, or it could be +2 and -1, or they could be switched. And then that 6x has to go here and here. So let's just guess and check. I'm going to try 3x and 2x because 3x times 2x equals 6x. I'm guessing and checking. Now let's check. There's -4x and there's 3x. I guessed right. I literally just guessed. I totally got lucky. So that actually worked because -4 plus 3 is -1. So that's how that factors right there. 3x minus 2, 2x plus 1. If that wasn't right, I would just switch the things around. And maybe I need a 6x here and an x there. Maybe I need a 2x here and a 3x there. I'm just guessing and checking and moving things around until I get my outside plus inside to equal what I want it to equal, because that's all factoring is. Let's do it for this one. Guess and check. Now remember, if this works right here, one of these two is going to be repeated right here or here. So which one of these two could be repeated? Could 3x plus 2 go here, minus 2? Is that possible to factor it that way? No, it's not possible because 2x squared has to be here. So I have to have a 2x and an x. So let's assume that this is going to be 2x plus 1. Otherwise, it was really not beneficial for us to factor in the first place. And so what would this have to be? X minus, it'd have to be an x minus 3 because I have a -3 right here. And does that work? 1x minus 6x. Sure does, because -6 plus 1 is -5. All right, so now that I've done that, that means that what I really have to do, see how that x plus 1, or sorry, 2x plus 1 is part of both of these? So this needs to be multiplied by the 3x minus 2 to get a common denominator. And this one right here, the 5x, that first fraction has to be multiplied by x minus 3 on the top and bottom. And that's going to give me, in my new fraction, it's going to give me the ability, because now I have now I have the common denominators, which is 2x plus 1, x minus 3, and 3x minus 2. See how that's on both denominators now? That's what I'm trying to do. I'm trying to get the denominators to be the same. And now the numerators are going to be 5x times x minus 3, which we'll clean up in a second, minus 6 times 3x minus 2. And now let's simplify that right there. I'm going to do it above right here. This right here is 5x squared minus 15x. And this here, be careful with that negative. Make sure you distribute that negative in. It's negative 18x plus 12. And now when I add these together, it's negative, 33? Negative 33x. So my answer is, I'm going to write this down at the bottom, 5x squared minus 33x plus 12. That's the numerator. And the denominator is 2x plus 1, x minus 3, 3x minus 2. And that's your answer. Now, if by some off chance this numerator factors, you might be able to factor it, but it's pretty doubtful that it does. It'd be pretty magical if it did. And if it did factor and cancel, then that would be, again, a shocker to me. But you know it's got to be 5x and x. So really all you have to worry about is if there's like an x minus 3. That's the only one you have to worry about maybe being up here. But it's not going to happen.